Hi, welcome back to this YouTube channel, ladies and gentlemen. It's nice having all of you around again. Um, we started talking about logarithm, I think, in the last lesson. So we want to continue logarithm and exponential functions in this particular video. It's meant to be a short one. So what we just have to do is to solve a couple of exercises on the board, and then you get an assignment. All right. So how do all of these things work? How do they work? So solution. Whenever you have a logarithm in this format, let's look at it. For example, if you have log, um, let's say AB equals Y. So how do you go about it? All right, so you just make A will lift this one. What do I mean? We are going to have B equals A raised to power Y. So logarithm here disappears, and then this A lifts up this other guy. So Y becomes the power of this base. A and Y, then we are left with B. So that's it. So that's just what we're going to be applying in everything that we are doing today. So for the first, okay, let me just do this on this way. So for the first question, log 36.84 equals x. So we have to find x. So basically what we have to do is 3 is going to lift up this guy. So therefore, 6.84 is then equal to 3 which per x. So how then do you get x? All right, so we can just take log of both sides. So what am I trying to say? Take log of both sides. So you have log 6.84 equals log 3 raised per x. So from here, log 6.84 is definitely going to give you a value, which I think I already have here. Um, 0 point log 6.84 is before I even do that, so I could just do something like this: log 6.84 equals x log 3. I believe you understand this. So divide both sides by log 3 by log 3 by log 3. So this cancel this. So we have x equals log 6.84 divided by log 3. So which is 0.8357 divided by 0.4771. I think we've been using log 3 a number of times. So this is going to give us 1.75. So x equals 1.75. And with that, we are true. So for the second question, which says log x 81 equals 4. So in this case, we do the same thing. It's going to become 81 equals x raised to power 4. Now this is kind of already easy, so we don't need to take log of both sides for this. So what we just have to do is, can we express 81, right, as an index of 4? So can we express 81 as an index of 4? And I think we can do that. So 81 is just 3 raised to power 4, right? So just 3 raised to power 4 equals x raised to power 4. So definitely x equals 3. And that solves that. So the reason why we had to take log of both sides here was that it's not going to be easy to like transform 6.84 in a form like this. So here we got 3 raised power x, and here it's even different because what we have here is not 3 raised power x. What we have here is x raised power 4. So you can see that it's a pretty simple thing to work with. So we move to the third question and the fourth question. As for the third question, that's not difficult at all. So I've moved it here. It's something that we can just solve in this place. All right, so we do the same thing. Um, 10 lifts minus 2. So we're definitely going to be having x equals 10 raised to power minus 2. So basically, this one is equal to x 1 over 10 square, which is 1 over 100. All right, so if you want to divide it, 0.001, I guess. So 100 would not go in this, 0.110 is still 0. Then I think 0.01. Okay, over 1, 1, 0, 2. So yeah, so that should be the answer. Now for D, which is looking like a little bit complex, so what can we do? It's going to be the same thing, just that it's looking a little bit funny. All right, so what do I mean? Remember that we can do this since all of them, this is base 4, this is base 4. So I could just do something like this: log 4. If you remember, x squared plus x plus 10, right? Then I bring this one in, minus log 4 x squared plus x minus 5, everything equals to half. So I've not done any big deal here. So just this one, right? Then I brought this guy inside here, minus and equals to half. So it's just looking long, but it's like a pretty much of a simple thing. All right, so applying this rule, if you remember, log m over n equals log m minus log n, right? So let me just put a recall. So recall this rule. So how are we going to apply that here? So this is going to become log 4 into brackets x squared plus x plus 10 divided by x squared plus x minus 5 plus the whole thing, then equals half. So from here I can simplify. I can make this guy come and lift this one up. So I will be left with x squared plus x plus 10 divided by x squared plus x minus 5, and this will be 4 raised to power half. So by now, from indices that we started from, you already understand that 4 raised to power half is same as 2. So it's basically root 4, same as 2. All right, so what I'm going to do is x squared plus x plus 10, right, divided by x squared plus x minus 5 equals to 2 over 1. Then I just cross multiply. 1 multiplied by everything, you're still going to give me what is there. So I have x squared plus x plus 10. All right, since it's multiplied by 1, then into bracket 2 equals 2 into bracket. I can multiply straightforward, in a straightforward manner, but it's because of some of us that like things step by step, get things better that way, as I'm like trying to like break it down to like smaller particles this way. So 2 multiplied by, I write this whole thing in brackets, x squared plus x minus 5. So one, the first reason why I'm doing this is so that people who like to like see things in a very simplified manner can understand them. And number two, so that you don't do a mistake, because students at this point they could just do 2 times x squared, 2x squared, 2 times x, 2x, then forget the minus 5 and write minus 5 here. So instead of you to also do 2 times minus 5 to give you minus 10, you can just forget and then write minus 5. So like let's just properly put the whole thing the way it should be written, like which is in this form. So you have to multiply everything here by 2. So we proceed from here, x squared plus x plus 10 equals 2x squared plus 2x then minus 10. So here, can we collect like terms? So if you collect like terms, you have x squared minus 2x squared, right? Then plus x plus this x minus this 2x plus 10. And when this guy comes, it becomes a plus 10 as well, equals 0. So x minus 2x, x squared minus 2x squared minus 2x squared, then plus this x minus, when this one jumps over here, becomes minus 2x plus 10, then minus 10 comes here, becomes a plus 10 as well. So don't just in a rush just say 10 cancel 10, thinking that it's going to become 10 minus 10 eventually. It's not 10 minus 10, it's 10. And when minus 10 comes here, it's like plus 10 plus 10. So x minus 2x squared is going to give us minus x squared, then plus x minus 2x, that's minus x, then plus 10 plus 10, which is plus 20, equals 0. So this is already giving us what do you call it now? This is giving us a quadratic equation. So what two numbers can we multiply that will give us minus 20x, then that will also give us minus x? So we need to find, I'm trying to use the completing the squares method, two numbers that you multiply, because the way completing the squares method work, which is something that's going to be treated in another class, or just learn it from here, anyways. So that means when you multiply this by this, that's going to give us 20 minus 20 x squared. So two numbers that when you multiply them will give you minus 20 x squared, and when you add them will give you minus x. When you add them will give what is in the middle here. When you multiply them will give you the multiplication of this and this. So if you look at it, what are the numbers that can go in 20? 10 can go, 2 can go, but there's no way you can do 10 plus 2, whatever, that will give you minus x. So let's use 5. Since this answer is in minus, so that means let's use 5 and 4. All right, so like plus 5x minus 4x will give us minus 20x squared. Like 5x times minus 4x gives us minus 20x squared. Or 5x, 5x plus minus 4x, it just give us x. It's not going to give us minus x. So which means what we need is um we need this one minus 5x then plus 4x. This will give us minus x. Then minus 5x times 4x will give us minus 20x squared. So that means the two numbers that we are looking for are minus 5x plus 4x. So we can just come back. We have minus x squared minus 5x, this one, plus 4x, then plus 20 equals 0. So what have we done here? It is this minus x here that we are representing as minus 5x plus 4x. So minus 5x plus 4x will give you minus x. So what we just did is we just kind of expanded this one a little bit. Minus x squared is still here. But instead of writing minus x, it's minus 5x, like something like this. Minus 5x. So this is like x squared plus minus 5x, then plus 4x, close the bracket. Should give you minus x back, then plus that. Alright, so continue from there. We are going to be having minus x squared, right? Um, minus x squared minus 5x, then plus 4x plus 20. All right, so everything equals 0. So what can we take out? Minus x. So if you take minus x out here, minus x is common. So minus x. And when we take minus x out, we are going to have just x in this place, x. We are going to have plus 5. Is that correct? Minus x times x is minus x squared. And then minus x times plus 5 will give us minus 5x. Then here I can collect 4 out. 4 into brackets. 4 in 4x is x plus 5 and equals 0. And because whenever we are, for those of you that don't know quadratic equation here, using the computing the squares method, whatever you have here in this bracket must be the same as what you have in this bracket to show that you are correct. So at this point, what we'll now do is that we pick one of these. Since two of them are the same, we pick one of it and then we pick what we have here and what we have here. So what am I trying to say? We have minus x plus 4, like this minus x plus this 4. Right then, this is like one of our answers, or we say since x plus y, just pick one of it, x plus 5 equals 0. So if you do minus x plus 4 equals 0, minus x equals minus 4, and x equals 4. So this is one possible answer for x. Then, or let me just rub this guy off. All right. So or second one is x plus 5. So x plus 5 equals 0 and x equals minus 5. So the two possible values of x, so x um, is equal to 4 comma minus 5. So that's we've been able to solve the given equation, that long one. So this one is log 4. So our x could be minus 5 and our x could be 4. So with that, we come to the end of this particular video. I also believe that you understand everything that went on here. It's not hard. So you're going to be having assessments, based on this kind of questions. For the first time, or for one of the fewest times or rarest times, right? We are going to be having like a very simple assignment. So find the value of x in the following. So log 10, log base 10 x equals 3. This one is too straightforward. Then this other one there, 2 log base x, then 3 raised power, not 3 raised power, rather 3 whole number 3 over 8, close the bracket equals 6. So that's all about your assignment. For students registered with us at Emotional Economics, you are likely going to be having more exercises on this particular kind of logarithm, because we are going to be preparing for like serious exams, and we want you to begin to like train yourselves in the kind of things that you probably or you likely come across in a given economics examination, or giving mathematical economics paper or something related, of some sort. So like we bring the class to an end here, and then next time we'll be talking about quadratic equations like fully, right? So from the beginning, continuous squares method, general function method, and specific kinds of quadratic equations too. I'm actually interested in those ones more, right? And so yeah, that'll be it. So after that, we go into other topics, other topics, other topics. So stick around. If you want us to do any video for you, you can just comment it in the comments box. We likely have the videos anyway, but if we don't, then we'll see if we can get something up for you. All right, so see you when I see you. Have fun.